Welcome to my channel. Good day out there, my good fans. I remain Dr. D.I. Jun, your lecturer on chemistry on social media. My last lecture was the absolute zero that was discovered by SARS concerning gases. And we have seen how the absolute zero temperature can also be converted to degrees Celsius and degrees Celsius to absolute degree, which is Kelvin. So let us now try to solve one of the problems concerning South's law. See on the board here, a sample of gas has a volume of 500 cm cube at 45 degrees Celsius. What volume will the gas occupy at 0 degrees Celsius when the pressure is constant? See it again. A sample of gas, a certain quantity of gas, has a volume of 500 cm cube at 45 degrees Celsius. Now, say, what volume will the gas occupy at 0 degrees Celsius when the pressure is constant? Okay. Now, if you are solving problems like this, before you go into solving, you can assess yourself. The law says that the temperature increases, the volume also increases. Temperature decreases, the volume also decreases. If you look at here, the temperature here was 45 and the volume was 500. Now the temperature is now reduced to 0. That's so that the volume you are going to get, the air you are going to get, must be less than 500. That's the meaning. The answer you are going to get from this calculation must be less than 500, because if it is more than 500, you have already got it wrong. But the temperature is decreasing from 45 now to 0. Now let's go. Solution. V1, which is your initial volume, is 500, as it is here on the question. Then your initial temperature is 45 degrees Celsius. So you convert it to degrees absolute by adding 273 to it. That gives you 3180 degrees Kelvin. V2, your final volume, that is what you're asked to look for. So what volume? So the V2 is not known. Then the T2, the final temperature, is what? 0 degrees Celsius. So by reason of South's law, you have to convert this to absolute. So 273 plus 0 to give you 27 degrees Kelvin. Now the formula, that is South's law now, V1 over T1 equal to V2 over T2. That is South's law already. Now, from this equation here, you can cross multiply. If you cross multiply this will be equal to this multiplying this. So look at it here. V2, that is this V2 here, T1 times this T1 here is equal to V1 here times T2. Now we are looking for V2, that is the subset of the equation. So when you take V2 out of this entity, this T1 has to cross the equality. When you cross it, it becomes a denominator. So that's why you have V2 equal to V1 T1 all over T1. So at this level, now you can now calculate, substitute the values. The V1 here is 500. So that's 500 you're seeing here. Then the T2 is 273 degrees. That's what you're seeing here. All over T1, the T1 is 318. That's what you're seeing here. If you use your calculator, multiply this by this, you get a value. Divide it by 318, you will get 429.2 cubic centimeter. So you can ask that the volume of the volume of the gas, you can ask that is less than 500. Because if it were more than 500, it means you are wrong. Because at this 45 degree, the volume was 500. So if the temperature is reduced to 0, it means the volume will have to go down. So you can see that now 429.2 is not up to 500. So that means we're right. So please like it, comment, share this video, and always remember to follow me and then subscribe to my YouTube channel.